not have a chair.
Okay, get out
Why
some
did nobody have a
paper.
chair? What happened?
I forgot my water.
What?
No, back to front. Where you find
I'm not finding it.
Okay, we're doing right now. Here,
I need a chair.
here,
Oh, no one needs it.
There?
Matthew, come on.
Should have some.
I need assistance.
You have to let them.
Is that your chair though?
I'm gonna grab me one of you. Ben, grab me one.
Guys, we're gonna start now.
Yeah, we're starting. You guys can't go anywhere.
Okay, 10.6. The special cases.
No more questions?
Not yet, we'll come back. Okay. The special cases. So sometimes when you're doing problems, okay, if you're using substitution and addition to eliminate, those two ways that we use, substitution or elimination, well, I should say add to eliminate. We get weird answers. There are weird answers that come out of it. So these are called our special cases. Now, if you think back to graphing, what were the two special cases in graphing that we would come across? One of them, we had no solution. When was that?
Slopes the same.
Slopes are the same. They were parallel lines, right? So one of them was when we have no solution because the lines are parallel. Okay, they have the same slopes. But we might not always see that when we're giving a problem. Okay? So the next case that's sometimes a problem, which we don't get as often, it's when we have all solutions because the lines are the same. So when they were right on top of each other, then we had all solutions because they really were the same line. They were just written in a different form. Okay. So when you're solving them by graphing, these are kind of easy to see. You can see if the lines are parallel, then you know there's no solution. You can see that the lines are on top of each other, so you know it's all solutions. So graphing shows these very well. But sometimes in substitution, that's not always the case. Okay? So let's say that we have this problem. Y equals 3x, no, negative 3x plus 4. And then we have y plus 3x equals negative 4. We are going to use substitution for this problem. Okay? We're going to solve this by substitution. That means I'm going to put negative 3x plus 4 in where the y is. Okay, so I'm going to substitute this for y. So what I'm going to get is negative 3x plus 4 equals, oops, not equals, plus 3x, because I put that in for y, and that equals negative 4. So all I did was replace the y with negative 3x plus 4. Now what happens here, look what happens. I have a negative 3x and a positive 3x. What happens?
They cancel out.
They cancel out. My variables disappear. Okay? In these cases, your variables will disappear. Okay? If they're either parallel lines or the same line, the variables will disappear. Okay? But let's see what we get for a result.
So
4 equals negative 4. Is that true?
No.
If it's not true, then there are no solutions. these two lines are parallel.
Oh.
We don't know what they're doing.
Should we go get our chairs?
We don't know what they're doing.
I got my chair.
I'm teaching, so you can do whatever you want. So here is one way that we can see that the lines have no solution, they're parallel, okay? If you come down to an answer with no variables, so notice, the variables go away, disappear, and if you get a not true statement, then they're parallel lines. Can anybody guess if they're the same line, how is that going to be different? Anybody guess? Yes.
Instead of negative 3x plus 4 would probably be negative 3x minus 4.
Well, yeah, no, I'm saying, how would the answer be different? How do you think the answer would be different if they're the same line? Parallel lines, the variables disappear, and what's going on here? They're not true. If it's the same, it will be a true statement. Okay, so we're going to make it that way now. We're going to say that y equals negative 3x minus 4, and we're going to say y plus 3x equals negative 4, and those are really the same line. Okay, they really are the same line. Okay, we're going to substitute in, because negative 3x minus 4 is the same as y. So I'm going to get negative 3x minus 4 plus 3x equals negative 4. The variables disappear because negative 3x and 3x, they cancel out. Variables disappeared. But in this case, I get negative 4 equals negative 4. That is true. If it's true, then they are the same lines, and all numbers are solutions. So those are your two special cases. So if when you're doing substitution or elimination, you lose all your variables, it means you either have a parallel line or two lines that are similar. And it depends on what you come down to, whether you say they're parallel or whether you say they are the same. Okay? If it's true, they're the same. If it's not true, that means they're parallel, they don't ever intersect, so there's no answer. They don't intersect anymore. Okay? So that's what you're looking at on that section. That's really all that we're doing right there. Okay, I'm going to end it. You may go get your chairs if you'd like.
Thanks for
No.